I'm here in Alibre Atom, and I want to test this against SolidWorks and FreeCAD. I've made cylinder heads in both of those, and so I want to make a cylinder head today. This will be a good comparison, especially because of the value that it brings as a paid software. You know, SolidWorks, NX, Creo, these were all very unattainable softwares, and this, starting at dirt cheap at a one-time cost for life, brings a whole lot of value, a lot more than you would get from other software. And so I want to make a cylinder head and go through what the process might look like. Hopefully it'll be a little bit of a different design than the other ones, but it would share a lot of similarity. So let's see, we're making these equal. Oh. And let's go with collinear. So hopefully this will shed some light on if it's worth the investment, which again, this is the hobby license. This is not the pro license. So it's going to be way cheap. And how does that compare against something like SolidWorks, which is super expensive every year instead of cheap once? So here I've got my sketch. In fact, let's make this 5.25, a little breathing room there. Let's deactivate the sketch and run an extrude. We're going to go mid-plane, and I want to go something like 15 inches deep, mid-plane, right? So that's our cylinder head. Looks like it works great. Thanks for watching. See you in the next video. No, I'm just kidding. I'll keep going. I'm going to grab the bottom end of my cylinder head and sketch on the bottom of this. And let's actually take a look at our bottom view here. That's better. I'm going to make two circles, right? These are going to reference two of the four combustion chambers on this cylinder head. In fact, you know what? What if we made a straight 6? I might just change my plans. Let's do a straight 6 cylinder head. For that, I'm seriously just making this up as I go, but it's going to make the modeling a lot more interesting and heavy. This is going to be a lot heavier than SolidWorks. So let's edit our feature and say plus 3.5 plus 3.5, right? Those are two more cylinder distances. So here we've got a straight 6. Let's activate this sketch, and I'm going to go to my bottom view, and the hotkeys are the same between this and SolidWorks. Control 1, 2, 3, 4 through 8 all control your views. Sweet. We're going to grab an equals. There we go. Let's grab a vertical. We're going to make these all vertical. Cool. So everything is vertical. Everything is equal. I like to just shorthand this 3.5. You can use construction geometry to make this a little bit better, right? 3.5. And then we're going to say 3.5 divided by 2. And then we're going to make all of these 3.25 in diameter. And that should make us fully constrained. This does not mark construction geometry as fully constrained or under constrained or anything. So let's grab a circle. Now, it is best practice to do this with 4 arcs that make a circle, but you can easily do this with a circle in Alibre. It fixes it for you. So let's go with 0.6, but even so, if this was a serious model, I would do 4 arcs, 0.6, but I'm having more fun here. Let's go with 0.9 in diameter. All right, so we've positioned our valve here, and let's deactivate the sketch. From here, I can highlight this face now, and I can project this sketch, right? So we're going to project a reference version of this sketch, and we're going to maintain association and say OK. And that gives me a good reference as to where this thing is. I'm going to create a line now. And just as we had done before, I can make this be kind of a true center rectangle with 2 constraints and 2 construction lines. So we're going to say collinear on these guys, and we're going to say equal, and bam, we have a true center rectangle. Next, we're going to make this, I did not mean to do that. We're going to make this 1 inch wide. We're going to make this 1.5 inches, good, and then maybe 2.25 inches up. That's looking good to me. So let's deactivate that. Now I want to make some planes. One that will reference the center of the first combustion chamber. So we're going to make a plane referenced off this little center XY plane, and actually get rid of this face. And we're going to offset this a distance of the typical distance between combustion chambers, 3.5 divided by 2 plus 3.5 plus 3.5. And that's a nice little bit of math that gives us what the center of our combustion chamber is going to be. Let's do this again, and this time we're going to offset it 0.6 inches, and that'll be the center of our valves, right? And so there's a few ways that if we want to change tree item names, we can. I will highlight this plane, rename, and say valve center plane. And here I'm going to readjust, not measure, rather, but grab this plane and rename. And we're going to say combustion chamber center. From here, I want to highlight my valve center plane and get an active sketch on it. I want to project this and my previous sketch here, and we'll do so in a reference with an association to their source. And this gives me some good options. First of all, let's do an arc. I guess that'll work. I'm going to go here to here, right? We're going to add a tangent. We're going to add a coincident. Right, and then we're going to add a vertical. And now I want to add an angle, and that should constrain everything. Let's say I want 7 degrees. In this case, 97 degrees off of vertical. That gives us a little straight right there, and that may not be quite long enough of a straight. Vertically, we're at 0.11 inches, so that might be a little bit short. I think what I'll do is get rid of my vertical relation here. In fact, I'll just get rid of this. We're going to add in a different arc. And I'm going to say perhaps I don't quite have to end on vertical here. Perhaps I will give this another tangent, and then let's end by constraining this line to be vertical. And that way I know how much allowance I have, and the dimension that I want vertically here is, let's say, 0.35. Oh, I don't like that though. What if I did another arc? Yeah, I guess there's only one choice. Alright, that it is. Next, let's do another one, and that'll be an arc. Whoop. From here to here, adding in a tangent again. Oh, you know what? I need to do this in a different sketch. Silly me. So we're going to actually deactivate, and let's do another sketch on the exact same plane. project, reference, maintain here and here. I'm going to do a line on this side this time, and I guess this is optional, right? You don't actually need this to define everything, but it gives you more control to do another guide curve, so it's just one of those things. It's up to you. Tangent. Let's do an angle. And this is going to be 90 minus 7 this time, right? 7 degrees. Or you can import the sketch that we've just made and set these lines to be parallel if you only want one angle to update if it will change in the future. We're going to take our arc center and maybe its endpoint and make sure that they are vertical. We're going to deactivate that. And now we have several options when we loft. So I'll run through a few even though I already know what I'm going to do. Whoops, we have to go to the subtractive section. And we're going to say subtractive loft, and I can initially just loft from this sketch to this sketch, and OK. And we get just a straight loft going from a rectangle to a circle. But of course we want an intake that's a little bit more organic than that. So I'm going to edit my loft, and one thing that I can try to do is specify a tangent to profile. This does not change very much as of right now. We still look like a pretty much straight rectangle to circle, because we have an option set, and that is minimize curvature. So we have to unselect minimize curvature, and that turns into a very organic loft into our combustion chamber, which is what we want. But you can see that this cross-sectional area is less than what the valve is, and that's no good, right? So you can try to tune this, right? We can tune it like 0.125 and 0.5 and try to give these special values to our normal vector, and we could say that maybe that's a little bit better. But instead of tuning it, of course, I've used guide curves. So I'm going to get rid of this entirely, select my guide curves, and go to sketches 4 and 5 and add those in. And when I select that, we get a very nice loft that does exactly what we want. So I think the guide curves are extremely helpful. Now, let me do a linear pattern. In fact, I don't need a pattern here. Why don't, because this is symmetrical, I can mirror, and that would be this option. And I'll choose this feature to mirror, my loft, and I've got a plane referencing the center of my combustion chamber, so I can select that. And now I have two of these. And it's pretty easy to mirror my mirror, which you can do in this program. We're going to mirror the plane over here. And we've done it, right? So now we want to make the actual cutout for the combustion chamber. I'm going to highlight my plane, which is the center of my combustion chamber. And let's activate my sketch. And from here, I'll just get normal. Let's make a line, another line, and another line. I can highlight this edge and add in a coincident relation. Let's make this the height of something like 0.25, and let's make this something smaller, like 0.05. We want 3 1/4 as we've sized before, so we're going to say 3.25 divided by 2 since it's a revolve. We'll grab an arc. We're going to make sure that this arc center is vertical. I also apparently need to add a vertical here as well. And then let's add, I can position this guy a little bit over here. We'll add an arc here that connects both points. We'll add in a tangent relation to both sides, here to here and here to here. Then we can give this a value, maybe 0.075. That looks kind of like a combustion chamber. So let's revolve this. Now I've got a sketch in a solid, So this could make for an interesting revolve, right? Because I can select the sketch, but when I go to select the axis, I don't think I can select anything. So instead, I'm going to actually suppress my solid real quick. And this, of course, leads to things breaking, but that's no big deal. We'll add in a revolve. We'll select our sketch. We'll select our axis, and you can see the little preview. And of course, we've done a revolve cut on a suppressed solid that doesn't exist right now. So it also gave me an error, right? The error says that there's no solid. But I'll simply unsuppress this. And now we have no errors and a nice combustion chamber. From here, I always wonder what the best thing to do next is, but I think I'm going to pattern this. And we're running a straight 6, which is going to be my first tutorial on a straight 6 cylinder head. I think it's going to be way cool. Let's go with a linear pattern. I'm going to pattern here, here. This is pretty straightforward because you just make sure that all the faces you want to pattern are highlighted. And I'm going to say linear path is going to be down this axis. We want 6 instances total, spaced at 3.5 inches. And I'm going to say OK, which, I've gone in the wrong direction. Let's pull that back up, right? We're going to edit that and change direction. And there we have it, right? So there's 6 features that are all looking the same. Next, how about I make a flange, flange on the side for an exhaust or intake manifold. I'm going to activate a sketch on this face, and let's go with a nice rectangle around here. I also want to project a sketch. We're going to create a sketch figure this time. I'm going to select the whole face and maintain association. Bam. All right, so now I'm going to choose this face and delete, 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 right? And that trims out what we don't need, but it leaves the lines around the intake or exhaust ports, which we do need. I'm going to make this simple, probably more simple than I have in the past. I'm going to say 0.5, takes us up to the top. 0.5, 0.5, 0.5. There we have that. I can add in sketch fillets, and those are pretty easy in this program. We're going to come over here to fillet. Right, we just choose 2 and apply. Now every subsequent fillet has an equal relation to the first of the same size to preserve your design intent, so you don't have to do a bunch all at the same time. And apply. Excellent, so let's close that. What else should I do? I'm going to space this out to 0.75, and that will give me room to add in a threaded stud. And I'll do the same over here. And I've got the room, of course. Let's deactivate the sketch and extrude. I'm going to do this to a distance of 0.25. And it looks like I need to reverse my direction. And for some reason I went to 4.2, right? So 0.25. There we go. So we've done that. Now why don't I add in some more kind of weight-saving measures. So we want a gasket to go all the way around here, maybe in between the 2 ports, but you don't need it in here. So maybe I can activate a sketch on this face. And I would like to, let's make something kind of funky to accommodate the studs. We're we're going to go with an arc. Not bad. Go with an arc here. Looks like we got an autosave coming. There we go. I want to actually, let's make reference circles here. Here and here. We're going to make those equal, and these are going to simulate the position of the studs. We're going to give that a dimension of 0.25. How about? So it'd be 1/4 inch studs. And I'm going to add a vertical relation on things that I think should be vertical. Whoops. But not like that. I'm going to go here to here. Alright, looks like that constraint was already there in some form. Now let's add in some horizontals right here. There should be a coincident there, so we'll add in a coincident, and just to make sure, yep, we have a coincident there already. So let's grab the dimensions. From here to say here, let's go with -0.1, and then from here to here, how about 125? Oh, that we need more than that. Right, so that should be good. Let's do the same. Also, might as well make these equal. And -0.1 and 0.25. Great. Let's try to click and drag anywhere that it's not constrained. It looks like magnitude or position on these are undefined. There we go. We just have to add some dimensions here. We can add in a nice wall thickness between this and the stud if we would like. 0.125. 1/8 inch should be fine. I'm planning on like a press fit stud or something like that. So let's deactivate. We'll do an extrude cut, and let's go. I drew that on the other side inadvertently. That's fine. Let's go to a depth of 0.25. And of course I needed to have reversed that, so let's reverse. Great, so now we can have some manifold studs coming out of this, and we can pattern this, right? So we're going to say linear pattern down this path. We want to change direction and reduce our pattern by 1. Okay, now we can also mirror, and we want to mirror this, the kind of flange and our pattern here, and we want to mirror it about this plane. You can see the preview. So there we have it. Right, and now now we have that. So let's jump on the YX plane. We're going to activate our sketch, and I actually want to get my view to the front, and I want to change my draw style so I can see the internal features. Let's go with shaded in all edges. One interesting thing that I can do is on sketch 5, I can go to my model, actually my sketch, project, sketch 5, create a reference figure. I have to click here, and sketch 5, not mirror 5, and maintain association. Now, when I go to my front, I have an outline of the very outer part of my profile. Of course, since this tangent line is going into a round profile, it's not going to be the absolute outside. This sketch will be. This also gives me relations to dimension off of, so it's very handy. Let's grab a circle here to here. It's a circle, I meant arc. It's kind of late at night, guys. Give me a break. I'm going to grab from here. We'll go with an arc. And let's go to vertical. We're going to make this vertical as well. I'm going to make a line. Let's grab a construction line now. From here to here, we'll make that vertical. Alright, from here to here, let's do a 0.375, which should give us plenty of room for a valve cover gasket. Let's go here. That's going to be 0.5 is way too big. Why don't I do this? It would be important to have a good wall thickness right here, right? That's more critical. So we're going to grab a wall thickness from here to here and say 0.125, right? So I have at least 1/8 of an inch protecting this inlet or outlet. Now we just need to dimension this guy, I guess. And before I've always done a flat bottom, but I want to make this a little bit more interesting with the curved bottom. So we're doing that. I'm going to give this a dimension, and we can go pretty deep on this, I guess. Let's go with 0.15. And we have another uncertainty here. There we go. We just have to add in a horizontal from here to here. Now we'll do a mirror, but for sketch entities, I'm just going to hit Control A. I have to get out of my constraints here. Control A, there we go. We're going to do a mirror across our line, and that came in fully constrained, so we're good there. It's going to be a long cylinder head. This will be cool. Let's do a deactivate sketch, cut extrude, and let's see, our original distance was 15 plus 3.5 plus 3.5, and let's minus 0.375 minus 0.375, right, to keep kind of a consistent depth. And then I should edit this to be mid-plane. And there we have consistent thicknesses, so that's looking pretty good. I can change my draw style back so it looks a little bit more clear. And we can add in something like shaded with visible edges. Might as well make my graphics look good while I'm at it too, right? So we're going to head over to the model. So that is our cylinder head so far. Now allow me to, well, how about I add my valves? So I'm going to, well, my valve guides. Let me go to here, and let me activate a sketch on this. I'm going to go to my front view as I do, and I'd like to project my existing sketch here to maintain source and create a reference figure. I'm going to create a line, right, and we said 7 degrees. We want 7 degrees, so I'm going to say 90 minus 7, right, and we're going to create a line, and I'm going to go just make this perpendicular for every line. I think I only need 3 perpendiculars, and then let's go with 0.05. And I'm still not fully constrained. I think I might need some, well, no, I guess I just have to do that magnitude, so I can make that any distance I want, really. as long as it goes through. So let's go with 5 inches. And deactivate. Let's go with a revolved cut. And I can choose my axis as this line. And now we've revolved, right? So we've got this nice hole. Let's start referencing this with an axis. So I'm going to make an axis, reference this circular face. And with an axis, we can easily define a plane, which is my next thing, right? So I choose an axis and a point, this guy right here, and I select my axis and any old vertex. I'm wondering if this lower one is selectable, and it is. Of course, that is nothing what I want. So I'm going to choose normal to axis, and that gives me a plane that is normal to where my valve is going to be going. And that's very advantageous for what I'm going to be doing here. I'm going to select this plane. And if that point down there didn't do anything really, I think this upper point would also work. So if you're having trouble following along in that regard, that point should be fine. I'm going to activate a sketch on my new plane. You can see how my sketch looks. And I want to, on my sketch, import. All right, so we're going to go to 2D sketch, project sketch. Let's import this, which should come in as a circle. We're going to maintain association, and we'll leave that driving. Now I'm going to add in another circle. And let's make this something like 3/4 of an inch, right? 0.75. Let's go with an extrusion. Let's go up to geometry. Now we don't really have an option to offset our extrusion off of the sketch, so it's just as well, I guess, to project the elements of face 2, and then I have a chance to extrude cut down to the size that I want. I was thinking more like 0.25 and going from there. And that went the wrong direction, so it didn't even cut anything, right? So let's edit that, and we can reverse. And let me step this up or down to about there, right? Nice low valve guide. That might not be enough face for the valve to stay stable on in real life, but this is just a demonstration, so I'm not trying to come up with a fully vetted design. In fact, it's pretty interesting the amount of times I get someone that seems critical of what I've done because of some aspect that this isn't like a fully vetted, completely feasible, 100% design. It's pretty interesting the expectations that some people have for a full design. Some people want me to go slower, some people want me to go faster. So I'm just trying to keep everybody happy, and I realize that it's an impossible task. Let's import just so that we have a nice center to reference off of, right? We're going to import here for a center, and I'm going to make a nice little valve perch. So I give this a little wall thickness, maybe 50 thou, just a little wall to keep the spring in place. And from here to here, right, that's a big spring, 1/4 inch thick, maybe 0.2. Give our valve wall a little bit more room. Let's deactivate and extrude. I want to extrude down to 0.125, let's say. That should be enough of a perch to hold the spring. So we're going to say OK there. And of course I've cut in the wrong direction again. This is just like an epidemic for me. Let's reverse. And there we have it, right? So we've done that. This will be a fun one. Why don't we go to our valve center plane again? I'm going to create an active sketch. And I'm going to jump onto the front view. Let's change the draw style back to all edges. Okay. You know what? It'd be even better to go with a wireframe, I think. Let's do that. So now I can see, let's go to 2D sketch. I can see this nice little valve axis. Reference, maintain. Instead of a rectangle, I'm going to go with 4 lines. It's kind of easier with a rectangle like this in Atom. I think the professional grade gives you some more rectangle drawing options. You can go 90, 90, 90. There we are. I think that this will be redundant. Yep. So now we're going to add in a parallel. And I've added in the wrong projection, right? I need to project this part of my sketch. The other part that I imported will be of no consequence, fortunately. Yeah, convert to reference. I guess I didn't do that. Now I have room to make this parallel. I can grab a coincident and get these 2 points together. Let's give this a dimension of how about 0.245? That might be too tall. We'll see. Let's give this another dimension. I want to go with 1 inch, well, 0.5 inch in radius, 1 inch in diameter, right? So 0.5. And let's go with deactivate, revolve. There's my axis. I keep forgetting that. I'm trying to select it in a solid. Let's go with that. Again, that might be too deep. It might be just right. I'm going to say view, solid. Yeah, that's looking like a nice valve seat. Great. So let's mirror some of this stuff and pattern it. I'm going to go with a linear pattern here, and our features pattern, we're going to go linear path to this direction. It's probably better form to choose an axis, right? And that's easy. You just choose this little axis right here. And along the Z pattern, we're going to choose, I'm going to choose this outer face. Extrusion, 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 revolution. Is that everything? I think there's another revolution. There we go. So that's everything. And nice pre-populates for us. We're going to change direction and add one more instance. Kaboom. But you know what? I think it might be easier if I edit this, if I take this down to 2 instances and set this to be 0.112, and that will cover, not quite, 0.6 times 2, right, that's 0.120, that's better. So now we have our valve seat on our other side. And then I can do a pattern of all the features and my pattern, right? So I'll start not there, but I'll start here. And then we're going to say extrusion, extrusion, revolution, and the pattern, and the revolution. And we can choose our linear path as the same axis, but this time we want 6 total features, I believe, in a different direction at a spacing of 3.5. Right, so there we have our cylinder head. Those valve guides are looking nice and low, which we're going to need because we need to fit a camshaft up there. Let's mirror. All right, we're going to mirror these features, and I'm going to go with, again with the very beginning, extrusion, revolution, extrusion, extrusion, revolution, pattern, pattern. So that should be everything. let's mirror it about this plane. Our preview looks nice. And it went through. No problems here. Hakuna Matata. We have valve seats on every cylinder, and everything looks like it has generated quite properly. So that is great. I'm going to save my model, and I've been going for 40 minutes, so this is probably a good stopping point before I lose everybody's attention span. As you can see, it's quick and easy to generate things in Alibre CAD. This was just 40 minutes, and I wasn't even planning on doing a straight 6. I just decided in the middle of this to make it a straight 6, which is going to be a lot heavier than the version I made in SolidWorks, because graphic calculations and everything is on an exponential scale. So this is probably going to be one heavy part, but I'm confident that Alibre can do this. It's got an ACIS kernel, and that's a really good geometric kernel. And this has just been a fantastic CAD platform. I highly recommend this platform. I think this does pretty much all the important stuff that SolidWorks does, but at a fraction of the price, a one-time investment, not a subscription, and it's at a price point that a hobbyist can afford. So I recommend FreeCAD first for everything because it's free. There's no risk, and if you need proprietary software that's going to have a ticket that you can open or a help desk that you can call, this is probably the best option. I mean, what a great platform for the price. I highly recommend it again. Check the link in the description. And thanks for watching. I'll see you in the next one. Don't forget to subscribe.